Hey everybody, Mr. Murray here. We are on Mr. Murray's Math Land talking about slope some more. Today we're going to focus on how to find the slope given the graph of a line. So instead of being given the coordinates of points, looking at it from a visual standpoint. So a little review, our formula for slope, which is the letter M, is y2 minus y1 over x2 minus x1, which is great if you have the two coordinates. We've also said that that can be abbreviated as delta y over delta x. That's the Greek letter delta, the triangle, and it stands for difference. Difference in y over difference in x. Or the phrase, which hopefully is familiar to you, and this is the one we're really going to focus on today when you're doing a visual kind of look at the graph, is rise over run. Rise over run, right? Rise is the change in y coordinates, which is how much you go up or down. And run is the change in x coordinates, which is the horizontal change. And you can just remember rise rhymes with y's. Rise rhymes with y's. So that's on top here. So first problem, let's just jump right into it. Find the slope of this line. And one thing you should definitely know before you even do any work, if you look at this as you're looking left to right, that's important, of course. This line is going up. This definitely has a positive slope. This is a positive rate of change. So my answer, when all is said and done, should be a positive number. Okay, so to tie this to doing it with a formula, you always need 2 points to do the slope, right? And it's very much the same when you're looking at a graph here. So you have to look through here and find points that you clearly know the line passes through. So like if I just point at a random spot here, I'm not sure exactly what those coordinates are, what those are, but ones that are, say, right there, I definitely know those coordinates. Right there, right there. So there's lots of them here, and you only need to focus on 2. You basically could pick any 2 of those points and calculate the slope, and you should get the same number because the rate of change of this line doesn't change as you go along. It's a line that's linear. Okay, so here's how you can do it to tie it to what we did in the other video. How about using the coordinates, even though this is not really the focus of this video? That focus on any one of those points. I don't know, the first one I think I did was right here, right? That y-intercept of the line, and the coordinates there are 0, -3. If I focus on another point, that point is 1, -1. Now you could do your slope using your formula, y2 minus y1 over x2 minus x1. And that would be, again, it doesn't matter the order so much as long as you're consistent. So if you say y2 is -1 minus the first y coordinate was -3 over the next, the x coordinate of 1 minus the first x coordinate of 0, and you see you get 1 minus -3 minus a negative becomes plus, and that will give you -1 plus 3 is 2 over 1, and that is, of course, 2 divided by 1 is 2. So we said today we're really doing this from a graph, we're doing this visually, so what we want to do is say, how could I do this without having to use the formula for coordinates? But I wanted to show you at least how you could use that if that was like all you were really comfortable with. But if you have a graph, watch how visual this can be, and this can be much faster than the formula. You want to still think about, hey, I need 2 points to focus on. So I'll even do the same 2 points. And for this, we said we're going to use the idea of rise over run. Okay, rise, which is the change in y, over run, which is the change in x. So look at these 2 points I've highlighted and just ask yourself, how do I get from one point to the next? Well, moving up and down, I have to go up and I have to go to the right. Up and to the right. So we're going to make a right triangle between the 2 points. And I went up 2. That's going up is a positive change, so that's +2. And going to the right is a positive change. When you go to the right on the x-axis, you're getting bigger, so that's a change of positive 1. And that first part, positive 2, that's the amount I went up, that's my rise. The amount I went to the right, that's my run. So you could just say, hey, I went up 2 over 1. And there's the same, 2 over 1 that we got from the formula, which is, of course, equal to 2. So when you have this graph in front of you, you could just do that super fast, counting boxes. Up 2 to the right 1. 2 over 1, 2. Bam. And I'd like to show that it really doesn't matter which 2 points you do and which order you go in. So for example, suppose you were really focused on these 2 points. I'm just going to say this point and this point. And you connect them with a right triangle. So now suppose you started with the one that is on the right here. And you said, okay, to get there, I have to go 2 to the left. I have to go 2 to the left. So going to the left, that's a negative rate of change. And going 2, that's 2 boxes. And then I have to go down from there. Well, going down is a negative rate of change. And that's going down 1, 2, 3, 4 boxes. So there's your rise. There's your run. So if you do it using those 2 numbers, my rise was negative 4, my run was negative 2, and look what you get. Negative divided by negative is positive, and 4 divided by 2 is still 2. So it really doesn't matter which 2 points you use, or even which direction you go in, as long as you're consistent. Okay, so let's just see a couple more examples here. And now we're going to do this purely from the graph without using the formula. So looking here, you got this. You should be able to tell that this line is going down. So my final answer should be negative if I've done it correctly, just like a good check. And you just need 2 points to focus on. So looking left to right, find 2 good points. It looks like there could be one, there could be one, there could be one. Not quite as many as the last one, but there's one and there's one. I'll focus on those 2. So when I do it visually, I'm focusing on that idea of rise over run. And to go from there to there, I have to go down 2. So going down 2 is negative 2. And I go to the right, positive 3. Going to the right is always a positive rate of change. So your run and your rise are those 2. My rise is the amount I went up or down. That's the vertical. I went down 2 and to the right 3. Negative divided by positive is negative, and 2/3 does not reduce. There's your answer, negative 2/3. And just look, those same 2 points, what if you thought about it this way? Hey, what if I start with that point and I have to go up 2? Well, that's a positive. And if you go to the left now, going to the left, that's subtracting 3. So you see, you'll get the same idea in the end. You'll get positive 2 divided by negative 3 when you do rise over run, and that positive divided by negative is still negative 2/3. Won't matter which 2 points you use, you'll get negative 2/3 in the end, which is why it's important, like I said, to take a second and look and say, hey, this answer should be negative. This line is going down. Okay. A couple more examples here. Find the slope of this line. Now this line, if you'll notice, is a horizontal line, right? It's perfect. It doesn't go up or down. So it doesn't have a positive or a negative slope. And if you're not sure, again, you could use the formula if you like, and you've got all kinds of points. Look, it passes through here, 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 here. And you might remember doing this, that your rise is 0, right? It doesn't go up or down. But your run, you could say, well, to get from there to there, that's going positive 1 or negative 1 if you go to the left, or however far you go, positive 2, positive 3. It won't really matter because you've got 0 on top, and 0 divided by any non-zero number is 0. And that, again, that is always going to be the case when you have a horizontal line. A horizontal line always has a slope of 0, right? 0 change in your bank account. It's not going up or down, 0 change. Not positive or negative. That's the one number that's non-positive, non-negative. Okay, and last example here, we've got a vertical line, and maybe you also remember this from the coordinates idea that now in this case, it's all rise, right? It's all going up and down, but there's 0 run. So when you think about it as rise over run, until you just basically start to memorize this, instantly, to go from any point, hey, my rise is +1 or, -1 or whatever you want to do going up or down, but your run is 0. You're not going left or right at all. So in the denominator, you have 0, and anything divided by 0 is undefined. Undefined, or you can use the no solution symbol, right? And we said that is, you can think of that like, this couldn't possibly be your bank account, for example, because your bank account can't instantly go up without any time passing, right? So it could be staying the same with a 0 change, or it could be going up as time goes on, or it could be going down. But your bank account, you can't just go up instantaneously, right? Or if you think about riding your bike, I can ride my bike on this, it's 0. I can ride my bike on this, it's positive. I can ride my bike on this, it's negative. I can't ride my bike up a straight hill, like up a wall. So any vertical line has an undefined slope. And you may have heard me say this in class, or you may have heard it from your teachers in the past, but a common phrase is hoi vux to help you remember these two things. And that is telling you that a horizontal line has a 0 slope. That's what the O stands for. It's actually a 0. And we'll talk more about equations of lines. That's what the Y will represent. And the V stands for vertical. A vertical line has an undefined slope. So the middle letter represents what kind of slope it has. 0 slope, undefined slope. Okay, so that's that. We saw a little of each here. Hopefully you feel comfortable. If you have any questions, let me know. And otherwise, hang in there. Keep working hard.